In this video, let us have an understanding of polynomials and some terms related to polynomials. Okay, this are few expressions written over here. I hope everyone has seen this type of expressions. Okay, now which expression is to be called as polynomial and which is not? Suppose here I take this 4 examples. So this is a polynomial. Okay, this is a polynomial, but this and this are not a polynomial. Now, on what basis we can say this is polynomial and these two are not the polynomials? Okay, so you can define polynomials as polynomial is an expression that consists of coefficients, or you can say constants, variables and arithmetic signs. Okay, that is plus, minus, multiplication, division, that all. So we have coefficients, we have variables, we have constant also. Okay, so according to this definition, all these expressions can be considered as polynomial, but still I am saying that this and this are not the polynomial. So for this we need to understand the second statement for polynomial definition is, in a polynomial, variables, or you can say power of variables should be in whole numbers. Okay, this is major criteria that will help you to identify any polynomial. Okay, so polynomial power of variables should be, or you can say must be, in whole number. Okay, so if you see here, this will give x power 1 by 2, and 1 by 2 is not a whole number. That's why this is not a whole number. Okay, if you see here, when this will go in numerator, it will give x power minus 2, and again minus 2 is not a whole number. That's why this is not a whole number. Okay, here root 2 is written, but we can see x is having a power of 1 only, which is a whole number. That's why these two are polynomials and these two are not the polynomials. So I hope you can see expression and say whether it is a polynomial or not. Okay, now let us understand few terms related to polynomial. To understand different terms of polynomial, I have made this table. So here I have written few examples of polynomials. Okay, so first we need to understand what is degree of polynomial. For degree of polynomial, we need to check the power of variables. The highest power of the variable in the expression is the degree of that polynomial. So here if you see, power of variable x is 3, here power is 1, and here as nothing is written, so we can say power is 0. Okay, so highest is 3. So degree of this polynomial or this expression will be 3. Like this we need to find the degree of polynomial. Okay, now here the power is 2 and power is 1. So we can say the degree here is 2. Likewise the degree here is 1. And here as no x is written, so we can take x power 0. So degree here becomes 0. Okay, and according to this degree only we can name the polynomial. So this polynomial where degree is 3, we can name it cubic polynomial. When the degree is 2, we can name it quadratic polynomial. When the degree is 1, it is known as linear polynomial. When the degree is 0, it is known as constant polynomial. There is one exception. If only 0 is written, then we cannot use this concept that we can write x power 0, so degree becomes 0. Okay, so this concept is not used. So 0 is an exception for which the degree is not defined. 0 is also a constant, but for this degree is not defined. And the polynomial name is 0 polynomial. Okay, so this is an exception for this. We cannot use this type of understanding in this 0. So 0, you need to remember this only. Okay, now what is the general form of this? General form of a linear polynomial is ax plus b. General form of a constant polynomial, it will be any constant. You can take a suppose. For quadratic, general form is ax square plus bx plus c. Okay, for cubic we have ax cube plus bx square plus cx plus d. This is the general form of the polynomials, respective polynomials written here. Okay, now next is the zeros of polynomial. Now first let us understand what do you mean by the zeros of polynomial. Suppose I am taking a polynomial as 3x square plus x minus 4. Suppose this is a polynomial. As the highest power is 2, we can say that it is a quadratic polynomial. Okay, this one. Now here, if I say this is a polynomial in x, we used to represent this like p of x, that is polynomial in x. You can take it gx, you can take it rx, whatever you want you can take. You can change the variable also. So we are taking the polynomials in one variable for now. Okay. Now suppose for here I take let x is equal to 1. If I take x is equal to 1, okay, first let us take x is equal to 2 suppose. We are taking x is equal to 2 suppose. So p of 2 will become, that is 3 into 2 square plus 2 minus 4. Okay, when you solve this you will get 3 into 4, that is 12 plus 2 minus 4. When you solve this again you will get p of 2 is equal to 10. This is 12 plus 2, 14 minus 4, that will be 10. So we can say that 10 is the value of this polynomial at x is equal to 2. Okay, this is read as 10 is the value of polynomial, this polynomial at x is equal to 2. Now suppose I take x is equal to 1 in this polynomial. So this will be px is equal to 3 into 1 square plus 1 minus 4. This will be 3 plus 1 minus 4. This will be 4 minus 4 and that will be equal to 0. So p of 1 is equal to 0. So 0 is the value of polynomial at x is equal to 1. Now when the value of polynomial becomes 0, we say this value of x is a 0 of polynomial. So how you can say what is 0 of polynomial? So 0 of polynomial is that value of x or variable for which the value of polynomial becomes 0. Okay, I hope you understood the difference between the value of polynomial and the 0 of polynomial. So x is equal to 1 is one of the 0 of this polynomial. Now we'll think that how many values of x, how many such values of x are possible for which the value of this polynomial will become 0. Okay, now that is also dependent on the degree of polynomial. Here the degree is 3, so we will get 3 zeros, 3 values of variable for which the value of that polynomial will be 0. Likewise, if degree is 2, we will get 2 zeros. If degree is 1, we will get 1 0. And here we will not get any 0 because it is a constant term. And there is no scope of putting any value of a variable, as there is no variable exists there. Okay, so I hope you understood. This was all about the basics of polynomial. Okay, majorly we are going to study about this quadratic polynomial only. Okay, now quadratic polynomial, if you talk about quadratic polynomial, that is ax square plus bx plus c. Okay, so this will be having 2 zeros as we have written here. Okay, suppose that 2 zeros are alpha and beta, any value we are taking. Suppose that 2 zeros are alpha and beta. Okay, now we have 2 more relations that will be used in this chapter, that is sum of zeros and product of zeros. Okay, that is actually the relationship between the zeros and the coefficients. Coefficients are the constant term attached to that variable. Okay, that is first is sum of zeros, that is alpha plus beta is equal to minus b by a. This is predefined relation, you just need to remember this. Okay, and the second relation is the product of zeros is equal to c by a. Okay, there is for cubic also, it is given in your book for NCERT, but cubic you just know the formula, that is enough. But we have to solve many problems related to this. Okay, so this relation you must know. So I hope the basics of polynomial is clear to everyone. Thank you.